On January 7th, 2026, more than 2 months after the most dangerous stretch of its journey was already behind it, a team of astronomers pointed the Subaru telescope in Hawaii at a fading object called 3I Atlas and found something that did not match what they had measured before. The ratio of carbon dioxide to water in its glowing cloud of gas had dropped sharply. That single number, buried in a spectrum nobody outside the field would think twice about, was the first hard evidence that this comet was not the same object on the way out that it had been on the way in. Something inside it had shifted. And to understand why that matters, you have to go back 6 months earlier, to the night a machine built to protect Earth from asteroids instead found something that had never belonged to our solar system at all. It was July 1st, 2025. In Rio Hurtado, Chile, a telescope belonging to NASA's ATLAS survey, short for the Asteroid Terrestrial Impact Last Alert System, caught a faint, fast-moving point of light. ATLAS exists for one job: scan the sky every night for anything on a collision course with Earth. This object wasn't on one, but it was moving in a way that planetary defense systems almost never see. ATLAS itself isn't a single instrument, but a network, 4 telescopes spread across Hawaii, Chile, and South Africa, built and funded by NASA specifically to scan the entire visible sky every night for anything that might threaten Earth. It has found plenty of ordinary near-Earth asteroids in its years of operation. It had never before found anything moving fast enough, and on a path steep enough, to rule out a solar system origin entirely. Within days, astronomers traced its path backward and confirmed what the numbers were screaming. This thing did not come from anywhere in our solar system. It had fallen in from interstellar space, on a trajectory so steep and so fast that the sun's gravity could never hold on to it. It was given a temporary designation, A11PL3Z, before earning its permanent name. Because it was the third such interstellar object ever confirmed, and because the ATLAS survey found it, it became 3I Atlas. Before it, there had been only 2 others in recorded history: Oumuamua in 2017, a strange, elongated rock that showed almost no cometary activity at all, and Borisov in 2019, a much more ordinary-looking icy visitor. 3I Atlas would turn out to be neither. It behaved like a comet from the very first images, but its chemistry was unlike anything native to our own solar system. Oumuamua puzzled astronomers precisely because it didn't act like a comet at all, showing no visible tail and no detectable outgassing, which is part of why speculation about its nature ran so wild for years afterward. Borisov, by contrast, behaved almost too normally, its chemistry falling well within the range seen in ordinary solar system comets, reassuring in its familiarity. 3I Atlas landed somewhere else entirely, unmistakably a comet with jets, a coma, and a tail, but carrying a chemical signature that immediately stood out from the local population. That combination, cometary behavior paired with foreign chemistry, is exactly what made this third visitor the most scientifically productive of the 3 by a wide margin. Here's the number that makes this object genuinely strange, not just rare. Its orbital eccentricity is roughly 14. For comparison, Earth's orbit has an eccentricity close to 0, almost a perfect circle. Anything above 1 means an orbit is hyperbolic, meaning the object is not gravitationally bound to the sun at all. It arrives once, swings through, and leaves, never to return. A number like 614 isn't just hyperbolic. It's emphatically, unmistakably hyperbolic. The signature of something moving so fast, it treats our entire solar system as a brief detour on a much longer journey between the stars. When 3I Atlas was first spotted, it was already traveling at roughly 137,000 miles per hour. By the time the sun's gravity finished pulling on it, that speed had climbed to around 153,000 miles per hour. This was never going to be a resident. It was always going to be a visitor that passed through once, and once only. If you've ever wondered why scientists get so worked up over objects like this, here's the plain version. Every planet, moon, asteroid, and comet native to our solar system formed from the same swirling disk of gas and dust 6 billion years ago. They share a common origin, a common chemical fingerprint, even with all their differences. An interstellar object doesn't. It formed around a different star, in a different disk, under different conditions, and then got flung out into the galaxy long before it ever crossed paths with us. Studying one is the closest thing astronomers have to sending a probe to another star system without actually building a spacecraft that could survive the trip. And that's exactly why. The moment 3I Atlas was confirmed, a genuinely enormous fleet of instruments turned toward it. Before we get into what they found, if you're the kind of person who wants the real story behind these headlines instead of the recycled version, this is a good moment to hit subscribe. Because this channel exists specifically to chase down the sourced, checkable version of stories like this one, not the version that gets flattened into a single dramatic sentence online. NASA's Hubble Space Telescope got some of the earliest useful data. On August 20th, 2025, Hubble imaging allowed astronomers to put real bounds on the size of the nucleus, the solid icy core buried inside the glowing coma. Their estimate? somewhere between 1,400 feet and 3. 5 miles across, a wide range but a meaningful one, because separating a tiny solid nucleus from a bright surrounding cloud of gas and dust from tens of millions of miles away is not an easy measurement to make. The coma, which is just the cloud of sublimating gas and dust surrounding the actual solid body, can be tens of thousands of kilometers across, even when the nucleus hiding inside it is barely a mile wide. And glare from that coma can easily overwhelm the faint light bouncing directly off the surface underneath. Hubble's imaging had to thread that needle carefully, which is exactly why the final estimate still spans such a wide range rather than landing on one precise figure. The James Webb Space Telescope weighed in next, using its near-infrared spectrograph to break the comet's light apart into a chemical fingerprint. What Webb found was odd from the start. The comet was unusually rich in carbon dioxide relative to water vapor, a ratio distinct from most comets that actually formed in our own solar system. Later, Webb's mid-infrared instruments picked up ratios of carbon isotopes and heavy hydrogen that didn't match typical solar system comets either. Hints, still being worked through, about just how different the environment around 3I Atlas's home star might have been. Webb also caught the comet releasing an unusually large amount of methane relative to its other gases. An odd enough result that researchers are still working through what it implies about the ices that formed inside this object in the first place. Some analysis of its dynamics has gone further still, suggesting 3I Atlas could be close to 12 billion years old, meaning the star system it originally formed around may no longer even exist in recognizable form. None of that is settled science yet. It's an active area of ongoing analysis, not a confirmed fact, and it's presented here exactly that way. But it gives you a sense of just how old and how genuinely foreign the material inside this comet might be. Then the fleet kept growing. NASA's SPHEREx observatory, a near-infrared space telescope designed mainly to survey the whole sky, took roughly a week's worth of dedicated observations. The Psyche spacecraft, on its way to a metal-rich asteroid deep in the main belt, caught 4 observations over 8 hours, useful confirmation data from yet another angle nobody had originally planned for when that mission launched. The Lucy spacecraft, en route to the Trojan asteroids near Jupiter, spotted 3I Atlas from about 240 million miles away, a genuinely huge distance for any meaningful detection at all, and a reminder that a spacecraft doesn't need to be anywhere near its target to still contribute useful science along the way. The Stereo mission, originally built to watch solar storms, stacked colorized images of the comet over time from its unusual vantage point away from Earth. The newer Punch mission, designed to study the solar wind, caught the comet's tail as a short elongation off to one side, almost as a bonus result. MAVEN, in orbit around Mars, primarily to study that planet's thin atmosphere, used its ultraviolet instrument to image the cloud of hydrogen atoms surrounding 3I Atlas's nucleus, repurposing a Mars-focused tool for an entirely different kind of target. This wasn't one telescope getting lucky. This was a coordinated agency-wide effort, and it kept expanding as the comet moved deeper into the solar system. ESA didn't sit this one out either. European Space Agency astronomers began tracking 3I Atlas from ground stations in Hawaii, Chile, and Australia almost as soon as it was confirmed. Then, in October and November of 2025, ESA did something remarkable. It turned 3 separate interplanetary spacecraft toward the comet purely to observe it. Mars Express and the ExoMars Trace Gas Orbiter both studied 3I Atlas around its closest approach to Mars on October 3, 2025, when the comet passed within about 29 million kilometers of the planet. NASA's own Mars Reconnaissance Orbiter joined in from the same vantage point, using its high-resolution imaging science experiment camera, known as HiRISE, to photograph the comet on October 2, 2025. From roughly 19 million miles away, a genuinely difficult shot for an instrument designed primarily to photograph the Martian surface just a few hundred kilometers below it, not a faint moving target tens of millions of miles out. The Jupiter Icy Moon's explorer, JUICE, on its own multi-year journey out to the Jovian system, also turned its cameras and science instruments toward the comet during this window. And in late November and early December, 2 X-ray telescopes, XRISM and XMM-Newton, detected something that had never been seen before from an interstellar object. A faint, diffuse X-ray glow surrounding the nucleus, making 3I Atlas the first interstellar comet ever observed in X-ray light. That glow forms when charged particles streaming out from the sun collide with gas escaping the comet, essentially lighting up the boundary where solar wind meets cometary outgassing, and detecting it at all from an object this faint required stacking observations from 2 separate orbiting X-ray observatories. Ground-based instruments contributed just as much as the space telescopes did. On November 16, 2025, barely 2 weeks after perihelion, astronomers used the Keck Cosmic Web Imager in Hawaii to capture the first post-perihelion blue-sensitive spectroscopy of the comet's coma. That data confirmed the presence of cyanide, iron, and nickel outgassing, all previously reported in earlier observations, and added fresh detections of two carbon chain molecules, C2 and C3, common in solar system comets, but not always seen this clearly in an interstellar one. The team behind that work calculated production rates for each of these species, essentially measuring how much of each gas the comet was shedding per second, numbers that feed directly into the same broader picture the Subaru team would refine 2 months later, a comet whose chemistry kept shifting the closer astronomers looked and the longer they watched. All of this attention, unsurprisingly, generated noise. As 3I Atlas's trajectory and unusual characteristics spread online, speculation started creeping in that this wasn't a comet at all, but some kind of artificial object, even a probe. NASA addressed it head-on. At a press briefing in Greenbelt, Maryland, covered by Reuters, Nicola Fox, Associate Administrator of NASA's Science Mission Directorate, pushed back directly on the idea, months into a tracking campaign that had already ruled out any realistic chance of a local origin. "It's natural to wonder what it is," she told reporters, before adding that the agency saw nothing in its behavior resembling a technosignature, nothing that separated it from a natural comet in any meaningful way. The SETI Institute ran its own dedicated search for exactly this kind of evidence, pointing radio instruments and optical detectors at the comet, specifically to look for the kind of narrowband signal or artificial light pattern that would separate a technological object from a natural one. It came up empty. No radio transmissions, no unexplained optical flashes, nothing beyond what a natural comet's own physics could account for, which is itself useful data, not a dead end. A negative result, carefully obtained across multiple wavelengths by a team specifically trained to look for this exact kind of signature, is still real science. And it's part of why the mainstream scientific consensus has stayed firmly on the side of a natural explanation, even as public curiosity kept building around the alternative. And that brings us to the moment the title of this video is actually about. Because a hyperbolic orbit with an eccentricity of 6, 14 has a very specific, very literal consequence. 3I Atlas was never going to swing back around for another pass. It has one perihelion, one closest approach to the sun, and then it is gone, permanently, headed back out into interstellar space along a path it will never retrace. That perihelion happened on October 29th and into October 30th, 2025, at a distance of about 36 astronomical units from the sun, somewhere between the orbits of Earth and Mars. For a short stretch around that date, the comet passed almost directly behind the sun as seen from Earth, making it briefly unobservable from the ground. Astrometric tracking resumed on October 31st. In the most direct, unglamorous sense possible, that perihelion passage was the actual point of no return, not a metaphor. A one-time geometric event baked into the mathematics of a hyperbolic orbit, after which this object could never again be gravitationally captured by our star. Compare that to any comet you've actually heard of before, Halley's Comet, for instance, which loops back past the sun roughly every 76 years because it's gravitationally bound in a long, stable elliptical orbit. 3I Atlas has no such orbit. There is no elliptical path to trace back around. There is one inbound leg, one hairpin turn around the sun dictated entirely by gravity and velocity, and one outbound leg carrying it away forever. Every telescope pointed at it during that window was documenting an event that would never repeat for this object ever again. Here's where the story stops being simple bookkeeping and starts getting genuinely strange. Before perihelion, in August 2025, the comet's activity was dominated by large icy dust grains, grains too cold to release much beyond carbon dioxide and carbon monoxide ice. That's consistent with what Webb and SPHEREx measured early on, that high carbon dioxide to water ratio. But by December 2025, after the comet had spent roughly 3.5 months inside what astronomers call the solar system's ice line, the boundary beyond which water ice can no longer stay frozen on a sunlit surface, the picture had shifted. According to researchers analyzing that December SPHEREx data, the comet was no longer just venting its most volatile ices. The bulk matrix of the comet itself, not just the surface layer, had started evaporating, releasing material from deeper inside the nucleus that hadn't been exposed before. More detailed analysis of that same December dataset was still ongoing as of early 2026, with researchers expecting additional SPHEREx survey passes to refine the picture further, adding yet another layer of confirmation on top of what Subaru would find just weeks later. Then came the Subaru telescope observation on January 7th, 2026, the one this whole story opened with. A team, led by Yoshiharu Shinaka, an astronomer at the Koyama Space Science Institute, analyzed the comet's coma using techniques originally developed for studying ordinary solar system comets. What they calculated was a carbon dioxide to water ratio noticeably lower than what Webb and SPHEREx had measured before perihelion. The team's findings were published in the Astronomical Journal on April 22, 2026, under the title, a post-perihelion constraint on the CO2-H2O ratio of interstellar comet 3I Atlas from OI, Forbidden Lines, a peer-reviewed paper that laid out, line by line, exactly how a set of faint oxygen emission lines in the coma could be used to back out the relative abundance of carbon dioxide and water. In their own words, describing the broader significance of the object, Shinaka and his co-authors called 3I Atlas a rare opportunity to investigate the physical and chemical properties of icy planetesimals that formed in a protoplanetary disk beyond our own solar system. The shifting ratio wasn't noise or measurement error. It pointed to something structural. The comet's interior composition is different from its exterior. As 3I Atlas heated up during its passage near the Sun, it wasn't just losing surface ice. It was, layer by layer, exposing material that had likely sat frozen and untouched since before our own solar system finished forming, and that newly exposed material had a different chemical signature than the crust that had been baked and altered by billions of years drifting through interstellar radiation. This is worth sitting with for a second, because it's easy to blow past a phrase like different interior composition without registering what it actually means. This comet, quite possibly, has spent billions of years as a frozen, layered object, its outer shell slowly cooked by cosmic rays and radiation during an unimaginably long journey between star systems, while its interior stayed essentially pristine, chemically unchanged since the moment it formed. Passing close to our Sun did something that had likely never happened to it before, not in this way. It started peeling back that outer shell and showing us, however briefly, what was underneath. That is the something that changed. Not a metaphorical transformation. A real, measured, sourced shift in the ratio of two specific molecules in a cloud of gas tracked across three separate observing campaigns using three different instruments, from before perihelion to more than 2 months after it. If a story like this is the kind of thing that keeps you up reading follow-up papers at 1 a.m, this is exactly the kind of channel worth sticking around for. So if you haven't already, now's a good moment to subscribe, because we're not done, and the next part of this story is where the scientific community actually starts disagreeing with itself. Not everyone reads the data on 3I Atlas the same way. Astrophysicist Avi Loeb, writing extensively about the comet throughout its passage, has cataloged what he describes as more than 20 separate anomalies in its behavior. A retrograde orbital plane aligned unusually closely with the ecliptic, a trajectory that brought it within tens of millions of kilometers of both Mars and Jupiter, a small but measurable non-gravitational acceleration caused by jets of outgassing material, and a collimated sunward jet, visible both before and after perihelion, that reversed direction relative to the comet's motion exactly at the point of closest approach. Loeb has argued these details are statistically unlikely enough, individually and combined, that they deserve serious scrutiny rather than automatic dismissal, and he's floated, carefully hedged, the possibility that some of what's been observed could theoretically be consistent with an artificial origin. It's important to be precise here. This is a minority position, actively debated within the field, not a confirmed finding, and mainstream analysis from NASA, ESA, and independent observatories around the world has consistently pointed to a natural cometary explanation that fits the data at least as well, if not better. Loeb himself has been careful to frame most of these points as open questions rather than settled conclusions, repeatedly stating that the evidence should be followed wherever it leads, rather than forced toward any predetermined answer, natural or otherwise. That framing is worth holding on to, because it's the difference between healthy scientific skepticism and simple speculation, and it's part of why his writing on the topic keeps getting engaged with by other researchers instead of dismissed outright. But the disagreement itself is real, it's ongoing, and it's part of what makes this object worth continuing to watch, rather than filing away as a solved case. The SETI Institute's involvement adds useful context to that debate. Frank Marcus, a planetary astronomer with the Institute, has framed the value of studying 3I Atlas in terms that go beyond this single object. Each one of these discoveries is a rehearsal, he said, describing the broader effort. And we are learning how to observe, interpret, and react quickly, so that next time we'll be ready to send a spacecraft. He made that comment during one of the SETI Institute's regular public discussions, where scientists and affiliates spent months walking through what the comet's passage had actually taught the field, separate from the noise surrounding it online. That comment points towards something concrete already in motion. The European Space Agency is developing a mission called Comet Interceptor, designed specifically to wait in space for the next qualifying object, whether a pristine solar system comet or another interstellar visitor, and actually rendezvous with it rather than simply watching from a distance. Everything learned from tracking 3I Atlas, every instrument that turned toward it late or missed the earliest data because nobody had a spacecraft ready and waiting, is directly informing how that next mission will be designed and deployed. Comet Interceptor is meant to sit parked at a stable gravitational point beyond Earth's orbit essentially waiting in ambush, so that when the next qualifying object is spotted, whether interstellar or simply a pristine, never-before-visited comet from our own solar system's outer reaches, the spacecraft can already be moving before the target even reaches its closest approach to the Sun. 3i Atlas made the case for that mission simply by demonstrating, repeatedly, how much gets learned when instruments are already watching rather than scrambling to catch up. 3i Atlas kept moving. On December 19, 2025, it made its closest approach to Earth at a distance of about 8 astronomical units, roughly 270 million kilometers. There was never any danger to our planet at that distance, or at any point in its trajectory, a fact NASA stated plainly and repeatedly throughout the entire campaign. From there, the comet continued outward, and on March 16, 2026, it passed its closest point to Jupiter at a distance of roughly 6 million kilometers. That number is close enough to Jupiter's Hill radius, the boundary of the region where Jupiter's own gravity dominates over the Sun's, that some researchers, Loeb among them, have flagged it as another curious coincidence layered on top of the others. A Mars approach, a Jupiter approach, a perihelion passage, timed to keep the comet hidden behind the Sun as seen from Earth. Taken individually, none of these numbers proves anything unusual. Orbital mechanics produces plenty of near misses and close alignments by pure chance across enough objects in enough years. But taken together, they're part of why this particular comet has generated more genuine published scientific disagreement than either of the 2 interstellar objects that came before it. By this point, 3i Atlas had already started fading. Ground-based images from March 2026 show a dim, shrinking point of light, its coma thinning as it pulled away from the Sun's heat and its outgassing slowed. As of the most recent tracking data available, the comet sits roughly 1 billion kilometers from Earth, about 6. 7 times the distance between the Earth and the Sun, well beyond Jupiter's orbit and continuing to recede. It will keep fading from every telescope currently capable of detecting it, and within the next year or two, 3i Atlas will pass beyond the reach of even the most sensitive instruments on or near Earth. It is not coming back. Not in 10 years, not in 10,000. The eccentricity of its orbit guarantees that, whatever star system it originally formed around, wherever it's ultimately headed next, this solar system was a single, unrepeatable stop on a journey that will likely outlast our entire species. So here's what actually happened, stripped of the dramatic framing but no less remarkable for it. An object older than our solar system, carrying chemistry unlike anything native to it, fell in from interstellar space, survived a coordinated, unprecedented observation campaign involving Hubble, Webb, SPHEREx, Psyche, Lucy, Stereo, Punch, MAVEN, Mars Express, ExoMars TGO, JUICE, XRISM, and XMM-Newton, past a genuine irreversible point of no return at perihelion on October 29, 2025, and then, in the months that followed, began revealing a structure nobody had fully anticipated. An outer shell chemically distinct from a deeper, more pristine interior, exposed for the first time in what may be billions of years. The disagreement over its stranger anomalies is real and unresolved. The mainstream conclusion that this is a natural comet with an unusually well-documented and scientifically rich passage through our solar system currently rests on the stronger body of evidence. But even setting the alien spacecraft debate aside entirely, the actual confirmed science here is remarkable on its own terms. We watched, in close to real time, as an object from another star system passed through ours exactly once, changed measurably in front of every instrument we had pointed at it, and then left, carrying its remaining secrets back out into the galaxy. Think back to that Subaru measurement from January 2026, the one this video opened with. A single ratio, carbon dioxide to water, shifting between one observation and the next. On its own, it's a small number in a table somewhere in an astronomy journal. In context, layered on top of everything that came before it. The Hubble sizing, the Webb spectroscopy, the Mars flybys, the X-ray glow nobody had ever detected from an interstellar object before, the Keck spectroscopy 2 weeks after perihelion, it becomes something else entirely. Direct, measured evidence that we watched a multi-billion-year-old object from another star system get partially peeled open by our own sun in real time, with enough instruments trained on it to actually catch the moment it happened. That is the something that changed. Not a rumor, not a guess. A number confirmed by a named researcher, published in a named journal, that tells us this comet is not the same object leaving our solar system that it was arriving in it. The next interstellar visitor is out there right now, on its own trajectory towards some star system we can't yet predict. And thanks to everything learned from 3i Atlas, the next time one crosses our path, we'll very likely be ready to do more than just watch. If you want to be here when that happens, subscribe now, because that story's coming, and it's going to be even stranger than this one.